All right, guys. So we are going to find a linear equation from a table of values. I know that this has been difficult for some of you guys, and that's okay. Um, Typically, looking at a set of numbers and coming up with an equation is not always the easiest thing to do, but we're going to give it a go here. I got a couple of examples set up as well as a couple of problems that you guys can try here at the end, along with the solutions to those problems so you guys can check your work. All right, so before we start this, we need to go back and take a look at the equation of a line. Now, the equation of the line that we're going to be looking at is slope-intercept. It's the easiest one to work with. Basically, we have two parts that we need to find, and I've color-coded them for your guys' convenience. We have here the M. The M is representative of the slope of the line or of the graph. Okay, but we're going to think of this as instead as the change in y over the change in x. That's going to allow us to calculate the slope or the rate of change so that we can find that m piece to that linear equation. Over here, I have the y-intercept. Now, something to note of the y-intercept, and I think you guys understand that when we say y-intercept, we mean the place where the graph of this data crosses the y-axis. There's something that we should note, and that's that the y-intercept here happens when x equals 0. And we're going to keep that in mind because if we can find when x is 0 here on the table, straight across from it, we should be able to find our y-intercept. So if I had a 0 right here, and on this side I had it, if I had a 0 right here, for whatever reason, on this side I had an 8. We would recognize 8 as the y-intercept because x is 0. It's not on here, and I'm gonna show you guys how to find that here in a second. But let's start off first with the rate of change or the slope. Again, there's only two pieces you have to find here. Start with the slope, and then go ahead and find your y-intercept. To find your slope or your rate of change, we got to do a little bit of work. We got to find some first differences. I'm pretty sure this is not a big deal for you guys. I'm adding one here, adding one here, adding one here. This is my change in x. I should recommend to you guys that you guys label. Too many kids get these get this upside down, and I think I know why. The x is on the top here, on the top row, the x variables, so people think that that goes on top, and because the y variables on the bottom, the change in y should go on the bottom. But no, it's always change in y over change in x. Here we're adding 3 each time. Now, this is my change in y. So I'm going to write down here, I'm going to write m equals my change in y over my change in x. And I just have to go and identify the pieces that I found. Now, this is constant here and this is constant here. That shouldn't come as a surprise. We were told to find the equation for the linear data. So we have a constant rate of change. So we have change in y is 3 divided by the change in x, which was 1. So 3 divided by 1, let's not get overcomplicated here and leave things when they could be simplified. That's just 3. Now for the y-intercept, I need to find when x is 0. And what I'm going to do is I'm going to use this pattern of x increasing by 1 and y increasing by 3 to work my way backwards. Now the reason I know I have to work backwards is because 0 is going to be to the left of 3 on the number line. If I continue going up, if I added 1 here, this would be 7. I add 1, it would be 8. It wouldn't get me any closer to 0. In fact, it'd get me further and further away. So what I'm going to do here, I'm going to erase this right here, and I'm going to label this as, I know these are my x's and these are my y's, and I'm going to work my way backwards. So if I go backwards 1, this would be 2. And you know what? Let's change that to a different color. Let's make that orange so we can distinguish the pieces that we had to add here. That would be 2. If I go backwards again, that would be 1. If I go backwards again, it gets me to 0. And I'm going to stop right there because I know x here is 0. So if I can identify the number that's across from it, that'll be my y-intercept. So down here, where things work a little bit different. Instead of going backwards by 1, I'm going to go backwards by 3. So 10 minus 3 is going to be 7. 7 minus 3 is going to be 4. And one more time, 4 minus 3 is going to be 1 plus 3. And I've found, and I told you guys I was going to make that different, didn't I? Let's change this to orange, including that one right there. This right here is my y-intercept. So I don't have to do any work. I've already done it up here. I'm just going to write b equals 1. And I found the two missing pieces, the m and the b here, for the y equals mx plus b format of the equation of a line. So I'm going to go ahead and just fill in the missing pieces. I got y equals (3), which is my rate of change, or my slope, x plus my y-intercept, which happens to be 1. So now I am done. I have found my equation of this for this data that represents this data. Y equals 3 times x plus 1. Okay, easy stuff, right? Let's try another example. Example number 2. I'm going to go ahead and write down again right here. Y equals, and I'll still color chunk it, mx plus b. And remind ourselves that, again, this is the y-intercept. Happens when x is 0. And this right here is going to be my slope, which is also known as my change in y or my change in x. And I'll continue to write that over and over again, as you guys should also. So the first thing I'm going to do is I'm going to find my slope, my my slope, my rate of change. I'm going to go ahead and find some differences here. I'm adding 2, adding 2. This will be interesting if you take -9 and you subtract -12. Well, what's actually happening here is we're adding 3 each time. We're getting closer and closer to 0. And so I have my change in y and my change in x. And I can do what I did before. I can write m. And you know what? I'll do it off to this side. M equals my change in y over my change in x, which happened to be my change in y was 2 and my change in x was 3. So change in y is 2 over 3. And in this case, it may look like ugly and you may want to change it to a decimal. Do not. Leave it as a fraction instead. Okay, so my y-intercept. Previously, what we did is we worked our way backwards. Now in this case, we're adding by 3. Notice that this is -12. Then this goes to -9, and this goes to -6. I'm actually getting closer. I'm getting closer to 0 if I move my way on down. So instead of going backwards, which would get me further away from 0, I'm gonna move my way down this table. So I'm gonna go ahead and add 3. And remember, I want to get to x equals 0. -6 plus 3 is -3. Whoops, and I told you guys, I'm sorry, that we would make that a different color. Let's add 3. That'll be -3. And if we add 3 one more time, -3 plus 3 is going to be 0. And I'm going to stop right there because, again, the x value here for the table is now 0. So I just need to find what 0 is paired up with here as far as y. So I'm going to, this one's adding by 2 on this side, so I'm going to go plus 2. That would be 16. And one more time, 18. So I have here my y-intercept. Again, I don't need to demonstrate any work here. I'm just going to write b equals 18. The work that I have here is demonstrating enough how I found it. You guys might want to write a sentence or two when you actually answer the question. But we have enough to write our equation. I have y which is our dependent variable, equals 2/3 okay, plus the y-intercept, which happened to be 18. And we have now our equation that represents our set of data. Pretty straightforward, pretty simple. We're actually giving you guys pretty easy tables that work out pretty nice. They don't always do that, but in our case right now, as we're learning this new material, we'll keep it as straightforward as possible. Now down here, I have a couple of examples for you guys that you guys can work your way through. I'm going to give you a chance right now. Go ahead and pause it and see if you guys can come up with the equations, because in a few seconds here, I'm going to go ahead and scroll down and show you what the solutions are supposed to be for this. One thing to point out is this is x and this is y. From now on, whenever you see a table written like this, the top will always be our independent variable and the bottom will always be our dependent variable, this bottom row. Okay, so there's no need to confuse you guys or make you guys find them. Just know that whenever we put x on, whatever we put in the top row here or in this first column will be our independent variable, and the dependent variable will always be on the bottom row or on this second column. All right, so I'm gonna go ahead and scroll down and give you guys the solutions to these. The only tricky one is I would say this part, this A. You don't have to do any work to find the y-intercept because x equals 0 is right here, so our y-intercept is 8. The slope can be found by taking your change in y, dividing it by your change in x, which gives you 6. Over here, similar to a problem that you guys have seen previously, again, to calculate my rate of change, that's my change in y, which is 10. Change in x is 10, and my change in y is 3. So that's why I have change in y 3 divided by 10. I work my way backwards 10, which would be 4 times in this case. I work my way backwards here by 3s to get 53 as my y-intercept. Hopefully that helps. You guys are more than welcome to find more examples online. There's an abundance in Google. Go ahead and just Google this top piece right here. Google this maybe, and a bunch of stuff will pop up, or come and ask me for more examples after class. All right, thanks guys.